INTLAIIVV. $3.95 to the ends of the universe. Isaac Asimov. Was the universe once a cosmic egg? And if so, how long ago did that egg explode, hurling flying fragments including our Earth into incredibly distant outer space? Will the universe go on expanding forever? Is it dying? Or is it unborn and eternal? Quasars, supernovae, and red and white dwarfs, they are all part of our universe. In this exciting book, these terms and many others, such as X-ray stars, VSOs, exploding galaxies, and neutrino bombardment, come alive with meaning. Starting with a small patch of the Earth's surface, Isaac Asimov takes the young reader on mankind's greatest adventure into the unknown, a journey to the ends of the observable universe, about 70,000,000,000,000,000,000,000,000,000,000,000 miles away. Lucidly and without condescension, he shows how this amazing enlargement of man's grasp of his physical environment was carried through in 2,500 years by means of that most powerful and wonderful of all instruments, the questioning human mind. Continued on back flap, 25 photographs. CJ Ului /I. W-C/ To the Ends. O.E. Walker and Company, New York. The Universe. Isaac Asimov. Copyright 1967 by Isaac Asimov, all rights reserved. No part of this book may be reproduced or transmitted in any form or by any means, electronic or mechanical, including photocopying, recording, or by any information storage and retrieval system, without permission in writing from the publisher. Simultaneously published in Canada by the Ryerson Press, Toronto. Library of Congress Catalog Card Number 67 to 23096, printed in the United States of America. Design by Roberta Kimmel. To Beth and Sam Walker for their warmth and charm. Books on Astronomy by Isaac Asimov. The Clock We Live on, The Kingdom of the Sun, The Double Planet, Planets for Man, with Stephen H. Dole. The Universe, The Moon, To the Ends of the Universe. Contents: 1. The Earth and the planets. 9. 2. The stars and the Milky Way. 23. 3. The globular clusters and the Magellanic Clouds. 32. 4. Nebulae and novae. 44. 5. The Earth and the Sun. 53. 6. Red giants and red dwarfs. 63. 7. White dwarfs and supernovae. 72. 8. Receding galaxies and star populations. S5. 9. The cosmic egg and the distant galaxies. 97. 10. X-ray stars and radio sources. 105. 11. Exploding galaxies and quasars. US suggested further reading. 32. Index. The planets. Is the Earth flat? When a youngster is taken on his first fairly long trip, he may be amazed at how far he can travel and how much there is to see. Until then, he had always been surrounded by the familiar streets or fields of home. Now he discovers that he can go on in a straight line for many miles and find new streets and new fields without end. Just how far out does the world stretch? Does it go on forever? The youngster of today learns the answer to such questions in school, but in ancient times, there was no such easy way out. Nobody knew whether the world went on forever or not. There were huge empires even in those days, and the armies of the king must have had a good notion of how many days' journey it was from end to end. They had to march it sometimes, yet no matter how far they marched there was no end. In 500 BC, for instance, the Persian Empire covered a large stretch of southwestern Asia, together with parts of neighboring Europe and Africa. It measured 3,000 miles from one border to another, but when men stood on any of the borders, they could see more land beyond. They could see more land, more people, with distant deserts, mountains, or seas on the horizon. Could it be, then, that the surface of the earth did really stretch on forever? Could it be that there was no end, however far one might travel? Some did not think so. The most scientifically minded people of ancient times were the Greeks, and the Greek geographers believed that there were limits to the earth, or at least to the land areas. If one traveled westward to Spain, one reached the ocean, which then stretched far out westward, northward, and southward, as far as the small ships dared sail. Travelers also reported an ocean to the east, near India. Perhaps the land came to an end in all directions and was surrounded on all sides by the ocean. A Greek geographer named Hecataeus, in 500 BC, drew a map of the world as he imagined it would have to be. He drew it as a flat disk of land surrounded by a rim of ocean. Cutting into the center of the land area from the west was the Mediterranean Sea. Europe lay to the north of that sea, Africa to the south, and Asia to the east. The earth, in his view, contained a circle of land about 5,000 miles across. World according to Hecataeus c. 500 BC. Hecataeus imagined the earth to be flat, and certainly it looks that way. Any one of us would take it for granted that the earth was flat if we weren't told otherwise. Yet could it really be flat? If it were, what was underneath it? What held it up? The ancient Hindus thought that the earth must stand on 4 pillars. But on what, then, did the pillars stand? 4 elephants, said the Hindus. And the elephants? On a giant turtle. And the turtle? It swam in a vast ocean. The Hindus didn't go beyond that, but obviously the next question was, what did the ocean rest on? And there was no end to such questions. Or a sphere. Perhaps, though, the Earth's surface was not flat. Travelers who went far southward noticed that some stars disappeared beyond the northern horizon, while other stars, new ones that had not been seen before, appeared above the southern horizon. When one traveled north, the situation was reversed. If the Earth's surface were flat, this should not happen. If it were curved, however, stars would disappear beyond the bulge in back as one traveled, and new ones would appear from behind the bulge in front. Much the same thing was noted in the case of ships setting out to sea. They did not merely grow smaller and smaller until they disappeared into a point, as would be expected if the Earth were flat. Instead, they disappeared bottom first. The hulls would seem to be beneath the surface of the sea, while the sails were still plainly visible. It was as though the ships were the disappearing hull. 60 = 9 * sails still visible / C _/ B dash : R5F 6J FABB B * J horizon hull hidden by curving surface dash the curve of the earth dash / the earth disappearing behind a hill. That was just what would be expected if the earth's surface curved. Ships always disappeared in this fashion no matter in what direction they sailed. The earth seemed to be curved equally in all directions. This possibility seemed to explain certain facts about ECUPSs of the moon. Such eclipses took place when the earth passed between the sun and the moon, so that the earth's shadow fell on the moon. This shadow always had a circular edge, no matter in which direction that shadow was cast. A solid object that has the same curve in every direction and that casts a circular shadow in every direction is a ball, or sphere. The feeling arose among the Greek philosophers that the earth must be a sphere in shape. This was first actually suggested about 450 BC. By Philolaus. If the earth is a sphere, why don't people fall off its bottom part? Why don't people feel themselves tipping as they travel thousands of miles in one direction or another? Why doesn't the whole earth fall? About 350 BC, the greatest of all the Greek philosophers, Aristotle, Aristofl, put forth the answer. He said that the direction down is always the direction pointing to the center of the earth, no matter where you stood upon it. In that case, up is always the direction away from the center of the earth. If that is true, nothing can fall off the earth, because everything falls down toward the center of the earth. And the earth itself can't fall because there is no place to fall to, it can only fall in toward itself, and it is already as far in as it can be. Ever since the time of Aristotle, learned people have accepted the idea that the earth is a sphere, for his arguments were good ones. The reason the earth looks flat is that the sphere is so large that the curve is too gentle to notice when we see only a tiny portion of the whole earth. Nowadays, of course, the idea is no longer as strange as it was in Aristotle's time. People have been traveling completely around the world for centuries. What's more, in very recent years, pictures of the Earth have been taken by rockets far out in space, and we can actually see that it is like a huge round bow. The size of the sphere. But if the Earth is a sphere, how large is that sphere? All of the land that the Greeks knew about was not enough to curve around and meet itself. One way to decide the circumference of the Earth, the distance around it, was to travel onward, measuring as one went, until one returned to the starting point. In ancient times, men could not possibly make such a journey, however, for the oceans that had to be crossed were too vast for their little ships. Fortunately, there were ways of deciding the size of the Earth without having to leave home. About 240 BC, the Greek geographer Eratosthenes, showed how that could be done. Eratosthenes lived in Alexandria, Egypt, a city which was at that time the center of Greek science. He knew that on June 21st, when the noonday sun was as high in the sky as it ever was, it reached zenith, the point exactly overhead, in Syene, an Egyptian city 500 miles south of Alexandria. At Alexandria, on the same day, the sun reached a position in the sky that was a little short of zenith. Eratosthenes decided that this was so because the Earth's surface curved. The sun's rays, which fell vertically upon one part of the surface, would fall with a height slant on another part, on a portion of the surface which had curved away. Eratosthenes' calculation of the size of the Earth. By measuring how far the sun fell short of zenith at Alexandria, Eratosthenes could calculate how much the Earth's surface had curved in the distance from Syene. He could then calculate how far the surface would have to stretch before curving in on itself and forming a large sphere. His figures showed him that the Earth was 25,000 miles in circumference and, therefore, 8,000 miles in diameter, that is, from side to side. It was more than 17 centuries later, in 1522 AD, before anyone successfully traveled all around the Earth. In that year, a single surviving ship of a Spanish fleet that had left under the leadership of the Portuguese navigator Ferdinand Magellan, finally made its way back to Spain after 3 years' passage through distant oceans. And Eratosthenes, who had never left home, turned out to be right in his measurement. The distance of the moon, but the spherical Earth, huge though it may be, is not all there is to the universe. Up above, on all sides of the Earth, is the sky, and in the sky are the sun, the moon, and the stars. If one observes the starry sky, night after night, one can't help but notice that the stars make up patterns that do not change. The whole sky seems to turn about the Earth every 24 hours, but all the stars seem to turn WDTH it. The stars each seem to be fixed in some particular place in the sky, and they are therefore called fixed stars. A very few of the brighter stars do seem to move, however. They may be near one star on a particular night and near another star several nights later. These wandering stars were called planets, from a Greek word meaning wandering, and the various ancient peoples named them after gods. We call them by the names of the Roman gods: Venus, Jupiter, Mars, Saturn, and Mercury. The moon also changes its position against the stars from night to night. Then, too, different parts of the sky are visible at night at different times of the year. This means that the sun blanks out different sections in the daytime so that the sun, too, wanders among the stars. Counting the sun and the moon, the Greeks decided there were 7 planets altogether. The Greeks supposed that the fixed stars were set into a solid sphere that represented the sky. This sphere rotated about the Earth, carrying the stars with it. The 7 planets, however, each followed an independent path, no 2 of which were alike. Each one was therefore supposed to have a turning sphere of its own, one that was transparent and could not be seen. In order to find out how large the universe was, then, one had to find out how large each of these spheres was. Naturally, one ought to begin with the innermost one, since that was the smallest. The moon's motion among the stars was faster than that of any of the other planets, so it seemed to the Greeks that the moon was the closest of all the heavenly bodies to the earth. This decision, we know now, was correct. Having determined the size of the earth, then, the next step was to find some way of working out the distance of the moon. The moon. Photograph from the Mount Wilson and Palomar observatories. The Greek astronomer